Hello, good afternoon. My name is Miguel Duarte. I'm here with my colleague Ora Murgi to present this talk titled Go BGP or Go Home, which is about simplifying KubeVirt ingress with your favorite routing protocol, which is BGP, by the way. So first, the agenda. We will begin with the motivation for having, or for simplifying. Is the audio on? Wow. Well, I don't know. Better now? Okay. No, let's fix this.
I think that it's even too loud now.
Just speak louder.
I'll shout if I have to. Better? Well, I think this is... Whoa. In the web, that'll suck. But again, I will try to speak as loud as I can. So, first, motivation. Well, if we keep at this, nobody was going to hear anything. But, so I think we will just carry on, and I apologize for people at home. First, why should we care about simplifying ingress? What is there for us in this? Second thing, why BGP? And then we will make a brief BGP introduction. We will describe the use cases we're tackling. We will describe our solution, show a couple of demos because it's always cool to see things that work, and we'll wrap this up with a few conclusions. So, I'm going to start this with a show of hands to make some sense out of this. So, who of you have used Kubernetes in the last years? Yeah, I guess a lot of you. KubeVirt? Okay, just a question. How do you expose a KubeVirt VM to the outside world? Like outside your cluster, you want to access in. Do I hear service anywhere? I heard service somewhere. Yeah, you would use a service. And how would you implement a Kubernetes service? Well, the solution is somewhere in the slide, and it's NAT. Thing is, NAT breaks your performance. We don't want that. Plus, some verticals based some of them because of performance, but for other reasons, they really hate NAT. Verticals like telco, financial services, they really dislike having this. So we want to try to avoid that. We do not want to have to expose a workload or a couple of ports on a workload using NAT. And on another separate topic, we want to simplify the Kubernetes admin life. We don't want them to have to be manually setting up routes on your clusters. So these are two things. Simplify the admin's life and getting rid of NAT complexity. This is what drives us. Now, why BGP? First off, it's an industry standard. It scales a lot, and it's proven to work well. It powers the whole internet, according to what they say. Another thing, policy control. You don't have to expose everything. You can have policy to describe what you want to import, what routes you're interested on, what things or what routes you want to expose to the outside world. Thus, you have a lot of control over how you design your traffic segmentation. And it is a routing protocol. You just deploy it, your routers will speak to one another, and they will scatter your network or the way to reach your network throughout the entire fabric. And those are the things that we are interested on. Very brief introduction about BGP, like fun facts, I guess, like this thing. I mean, some of you today could like be inventing the next cool thing like BGP. If you go for dinner, have a few beers, write a state machine on a napkin, this could be it. 20 years from now or 40, we'll be here hearing about it. Now, going back to what we're here, we are providing an integration between KubeVirt, so we run virtual machines in Kubernetes clusters, and BGP. And for that, we are using a particular CNI one particular CNI plugin. This won't work with all of them. This will work with one specific one. It is Oven Kubernetes. Oven Kubernetes is a CNCF project, and it pretty much translates from Kubernetes API, so things like services, pods, network policy, and translates that into Oven lingo or Oven entities. Good question. What is Oven? So Oven is an SDN control plane to Open vSwitches. So it just orchestrates a bunch of Open vSwitches which would run each on a dedicated node. And it supports KubeVirt virtual machines. By this we mean that it has special code, like it understands that a pod holds a VM and does special stuff to it, and it is the default network provider for, well, for at least one downstream distribution of Kubernetes. Then, how do we implement BGP? This is implemented using open source, so we are using FRR. FRR is pretty much like an open source implementation of a router, and in the Kubernetes ecosystem that is exposed to the cluster or packaged into the cluster with FRR Kubernetes, which integrates with Oven Kubernetes in a way we will see in a few minutes. So, how does this work in real life? So, each of the nodes in your cluster will be running an FRR Kubernetes pod, which means that it is running a packaged bundled version of FRR. And this router will communicate with your cluster edge router, which will propagate your routes or import routes from the fabric, which could be the internet, and would connect to, let's say, your thing that is running somewhere else via a provider edge router for you to access your provider network. Now, for the use cases, I will leave it to my colleague. Over.
Thank you. Hello. So let's present a few use cases that we find interesting in our customers. So the first use case is to getting access to the provider network. This is the painful point where you need to mess around with services and this kind of stuff. So the use case is basically to enable a pod or VM to access your cloud network or provider network. So we do that by importing the provider network routes into the cluster network. We use BGP for that, and we have a few custom resources that to control it. We will see it in a few moments in the demo. And this resource is called FRR configuration. Remember this name, we will see it in a few. And the other use case is the other way around, is to expose your cluster network provider into the outside. It means that you enable services running on your cloud network to tap into your VMs or pods. We do that with two resources, the same as I mentioned earlier, the FRR configuration, and another resource called route advertisement. And now let's get to a few implementation details. So API, we have two resources as I mentioned. One is FRR configuration. This resource controls with whom to peer with. It controls who are my neighbors, which means the BGP routers that I want to connect to and to manage the sessions, what their autonomous system number, and which node to consume this configuration. It's provide granular configuration that allows you to take subset of nodes and do the BGP session over them and not your whole cluster. And the other resource called route advertisement. This one controls what to advertise in your BGP session. It means it can be pod network, your cluster default network, pod network, another name, or user-defined networks, secondary networks, and which FRR configuration to use for that. Yeah, this is the resource set. So let's talk about the relationships between OVNK, Oven Kubernetes, and FRR instances. So we have OVN Kubernetes. It monitors your each node kernel routing tables, and it provisions FRR configurations according to your to the API to your configuration that you want to make. FRR Kubernetes take these configurations and translate it to the router configuration running on your each node instance. It's pretty straightforward. This is how it's done. In addition to the FRR configuration, Open Kubernetes also monitors the root advertisement resource that I mentioned earlier. And according to that, he again translated to FRR configuration and so on until your node router configuration. And one more nice topic is the failover capability using the bidirectional forwarding detection, for BFD for short. This is basically what makes BGP to enable high availability and failover to the next best route. So BFD is the protocol for detecting faulty links between two devices. Device can be a switch or a router. BGP utilizes it to detect broken links and converge to alternate one. And it ensures rapid failover and high availability, which is essential for production application and minimize the downtime. And with that, we will see a few demos by Miguel. The floor is yours.
So I'm going to try this now. Yeah, works a lot better. Should have thought of that before. Yeah, so you can scan this to access the demo, but I will be showing it. I really hope the font is big enough. And let us begin. So first thing, we are using a kind cluster for this, plus a couple of containers that are deployed on the laptop. So we have our kind nodes right there. So we have Oven control plane, Oven worker 2, like fairly intuitive naming. And then we have two extra containers. We have FRR and we have BGP server. So the setup we are running is kind of FRR is a router, obviously. And then you have BGP server, which is connected directly into the router. And then you have the Kubernetes cluster containers, which are also connected to the router. So FRR has two interfaces, one connected to a switch, which interconnects with the Kubernetes nodes, and it has a second interface, which connects to the BGP server. The default route in BGP server is the router. Okay, what are we going to see? I'm going to start the script that does this, and this is the configuration that we have. So we have our cluster ASN, so 64.512. I mean, just has to be a number. And then the network we want to import. So remember, we have policy. It's not like I'm going to, I don't know, bring all the routes from the outside world. No, I just want to be able to reach this specific route. So you have policy for that. This is the prefix we want to import, 172.26.00/16. And we are deploying a virtual machine in our cluster as well. I think that is it. Oh, and important, like the BGP server. So the container that we have outside the cluster is has this IP address, so the .3 IP. Okay. So, okay, this is the FRR configuration. Remember what Or told us? This defines the neighbors. So you're specifying whom to peer with here. So you're defining one router in your cluster, the ASN I told you about, and this router has two neighbors, one using an IPv4 address, another using an IPv6 address. Essentially, it's the same router. The router is just dual stack. So as you see, .5 address both in the IPv4 and the IPv6 address. And we define here in this to receive allowed, you're saying, I just want to import this particular prefix from the fabric. It could have been like in the allowed stanza, it could have been like all, and you'd have import everything that the fabric knows about. You would bring that down to your cluster routers. That's not what we want. We just want this particular prefix. Okay, this just shows that the routers are running in each of the nodes, and now we are provisioning the IP address. provisioning the virtual machine. We see it is scheduling. Move this forward. Okay, so it is now running. It got an IP address. So it just has the cluster default network attachment. And I'm showing here, yeah, the VMI spec for this virtual machine. And the interesting thing here, it just has the cluster default network attachment. So you see here, masquerade interface type. Okay, now what I'm going to do is to show the routes on the nodes itself. So I created a debug pod on the oven worker, which is where our virtual machine was scheduled on. And as we see, we have imported this route from the fabric. So you see this 172.26.0.0/16 is a route on, well, on the cluster nodes. And what we'll do now is access the BGP server thing, which is located outside the cluster. So for that, we console into our VM, Fedora password, and we will now ping the IP address that is saying right here, and we can ping it, and we can also curl the thing, which is what we wanted to show in this first demo. Okay, we can see the ping again. Now what I want to show is that this is actually doing something, so I'm going to delete the configuration, thus saying that my router is no longer connected to this. We see here the FR configuration. And, okay, so you notice the ping, still going, still going. Going to delete it. And the ping stopped. And what I'm going to do again is I'm going to provision, like the script is declarative, so it does nothing if it already exists, but one of the things it does is provision again the FRR configuration, so the ping resumes working. And this includes our first demo in which we try to access a provider network. Let's move to the second one, which shows the second use case or told us about, in which we want to advertise to the outside world our internal network or our cluster network. So for that we use this second script. We are using iBGP here. We can see that from it's gone. From the cluster ASN, external ASN, they're the same, so iBGP, our neighbor, the .5 address, we are no longer using dual stack for this. We could, there's no reason to, so let's not. Now, interesting enough, the cluster network we want to advertise to the outside world is this prefix right here, so 10.100.0.0/16. We want to advertise the pod network. And the provider service that we have outside the cluster is that IP address, the same one as we had before. So this is the FRR configuration. As you see, the only difference is in the allowed, it has mode all. So I want to import everything the fabric tells me. Don't do this in production ever. And this is how we configure our UDN. So this is an isolated network. This is just a detail. So let's skip over it, and this is the relevant part we have right here. So this is the second CR that Org told us about. This is the route advertisements thing. So while the other told us whom to peer with, this will tell us what are we advertising or exposing to the outside world. So we want to use the FRR configuration, so we want to define we want to consume the neighbors that we've defined on FRR configurations with these labels. And we want to expose the networks that has this label right here. And that is pretty much it. Let's see what happens when we do it. Because again, remember, our second use case, the thing we will be seeing now is how can we get rid of that and not have to use a Kubernetes service to access into our workloads. Okay, the router pods are running. I'm scheduling the VM. Scheduling, scheduled, running.
has an IP address in the range of the network we want to expose. I'm going to copy that IP address. Now I'm showing the routes in the fabric, right? So interesting enough, you'll see here that the fabric knows a way to access this prefix and knows how to reach it in 3 different ways. So you can use either these 3 next hop IP addresses to reach into that. Why those 3? Like, these are the 3 cluster nodes that we have. Like, so this means that the traffic could go into a workload into any of these IPs. Yeah, here you see the exact same thing, but not using like FRR API, just the typical route table on your nodes. And we can now we will Docker exec into our container and try to reach into the VM we have deployed on this isolated network. So Docker exec BGP server. And we will ping the IP address that we are seeing right there. And it is working, which is what we hope to see. So you're exposing a workload running on a Kubernetes cluster directly using its IP. We did not have to create a service. There's no NAT involved. This is literally what we wanted to show. Now I'm going to do the exact same thing I did before. I'm going to delete the route advertisements, and we're going to be seeing that the ping will stop. I could have done the same thing as I did before. I could move the FR configuration. The result would have been the same. As we see it stopped, I'm going to do the same thing again, run the entire script, which is idempotent, which will make the ping resume working. And it has resumed. So, or take it away. And wrapping up with some conclusions.
Thank you. So before we go, we want you to go with the following points. So we saw the integration between OVN Kubernetes and FRR Kubernetes that allows us to connect workloads over BGP and drop the excessive service configuration and have seamless, somewhat seamless experience of exposing your VMs or pods outside. And the most important thing is that you can reach your VM with its original IP. No NAT, no fun stuff and weird IPs. We saw that the integration with the provider network is dynamic. It means that if something fails in your provider network, thanks to BGP, it will recover and learn your provider fabric routes and distributes them to your nodes. So you don't need to do manual configurations, and it's just make your admin happier because it has less jobs to do, less work to do. And as he's no longer need to mess with annoying static configurations and manual work. And as we mentioned earlier, we finally drop the NAT overhead and annoying configuration, the ingressing the VM and exposing it is by its original IP. So, and this feature is something that our customers looked for a long time, and it makes it makes them happier and their admin happier. And this is the end. We have a few resources. We have the BGP, nice BGP intro, the project's docs, and the integration doc. It's pretty straightforward. I hope you find it useful. And that's all. Thank you. Are there any questions? Yes? Yes, please.
Do you happen to have some set of metrics where it shows how much improved the performance is going the BGP way compared to not.
So the question was whether we have some metrics to compare between how we improve the network between comparing BGP to NAT configuration. So rough metrics for that would be like 40% for the NAT overhead, and we didn't even talk about the underlying network that maybe use VXLAN and other encapsulation protocols. This is basically it. Do we have more time? Yes. So the question was whether the VM can ingress and egress with the same IP. Do you want to take this, Miguel? Yeah.
So the thing about the egress IPs is you'll be pretty much just advertising that to the network as well. So the answer is yes, pretty much. If you're using it to egress, we want to try to force it to go in the same way. Otherwise, your contract tables would go bananas. Your traffic could get dropped somewhere and debugging nightmare. Yeah, that's partially one of the reasons why that feature, that integration was created. Sorry? I do not know what those are, sorry. And I think time's up. Sorry, you can catch us outside, okay?
For more questions, please go
Yep.
outside. Thank you.